algorithm itself, how many number of times the recursive function t of n minus 1, right? And here, if I want to, so can I write like this? T of n minus 1, I am taking all the others to be as a constant. So finally I have arrived t of n minus 1 plus 1. Okay. So now, for this, if I want to write a recurrence relation, how to write the recurrence relation first? With the backward substitution. Previously we have seen three methods, right? So now what I am doing is t of n minus 1 plus 1. At what time does t of n minus 1 plus 1? When n is greater than 0. When n is equal to 0, it is of a constant. In this way only you have to write. Whatever the t of n value that arrives for you, with that what you have to do is, you know what is the condition? T of n minus 1 plus 1 is the function you have arrived, t of n function. So when it is t of n minus 1 plus 1, when n is greater than 0. When n is equal to 0, what it is a constant time. You don't know, you won't take 0 value, you will be taking 1, always 1. Right? Okay. So now, what is t of n now? T of n is equal to t of n minus 1 plus 1. Okay, let me go with the backward substitution now. Okay, so we can go with the backward substitution. How to do the backward substitution? We know t of n is equal to t of n minus 1 plus 1. If I substitute n minus 1 for n, if I substitute n minus 1 for n, so what it will do? T of n minus 1 is equal to t of n minus 1. N minus 1 minus 1 will be of minus 2, correct? Plus 1, am I right? Is it fine? How many of them have done this? Now I am substituting, you have to listen carefully. Now I am substituting n minus 1 for n. If I substitute n minus 1 for n, what will be the value?
n minus 2 plus 1
T of n minus 2
plus 1.
plus 1, and then we have one more plus 1, right? Okay, if I substitute here, this is, I am substituting here in t of n minus 1. Now I am substituting here t of n minus 1 is equal to, what is this? T of n minus 2 plus 1. Correct? For n minus 1 I am substituting. Instead of n minus 1, I am substituting this. Is that fine? Any doubts so far? Here? So now, like this, what is t of n minus 2? T of n minus 3 plus 1, is that fine? Can I write like this? Clear? Okay. So if I substitute this for t of n minus 2, so what it will be? Instead of this, t of n minus 3 plus 1
Plus 1.
it goes on. Yes. Minus 2. Yeah. See, instead of n I am making n minus 1. That's all. Instead of n, I am going to give n minus 1. So here, when I do this, see, listen. Now instead of n, I am making n minus 1. So for n minus 1, this is the value. This thing I am Correct one. T of n is equal to, is it fine now? T of n minus n, because you are substituting here. So T of n is equal to T of n minus 3 plus 1 plus 1. Is that fine? Okay. These are constants. Plus 2, plus 3, plus 4. All we are going to ignore all. Right? Okay. So now it goes on till what? T of n minus k. Yes? So this is the way we have done. If you think about time complexities and all, so how we have traced? So how it goes? It goes till, we don't know how many times it goes. If I keep on substituting this, T of n minus 3, n minus 4, n minus 5, n minus 6, I don't know, T of n minus k. Right? So when the condition is getting stopped, T of n minus k. Correct? T of n minus k plus 1. So if I keep on going like this, so what will happen then? Can I substitute here? T of n minus k. So what is the condition? This condition goes on till when n is greater than 0. Yes or no? This is till when n is greater than 0. When this condition is going to get stopped? Equal to or less than enough. So how can we write this? Can I write like this? T of n is equal to T of n minus k. Plus this is also a constant, right? It is going to keep on, plus this will be a 2, this will be 3, this will be 4, it goes keep on, the constant is also getting increased. Right? So I have to add plus 1 plus 1. Okay. So when you do this, you will be getting this. Okay. So we know that n minus k is, this condition is going to get stopped when it is equal to or when it is less than. So I am making n minus k equal to 0. So k equal to n. Right? Okay. So then instead of k or instead of k I substitute n. So T of n is equal to T of n minus n plus n. Is that fine? Is that fine now? So I will be getting T of 0 plus n. What is T of 0? 1 plus n. What is the this order of? So what we have got in the back tree method? What is the value? N times O of n. So you will be getting the same. Even if you go with the backward substitution or even if you go with the tree tracing method, the answer is going to be same.